In this video, we're testing claims about the mean. It should be a little bit easier than some of the complicated calculations we were doing last time. We just want confidence intervals, so you go into your stats menu, enter Z, one sample. This is volume of milk, it's normally distributed, that's good. The mean can be adjusted and the standard deviation is 10. So they're after a 95% confidence level, so 0.95. It's kind of like the standard. Standard deviation here, I think they said is 10 mils. X bar, all right, so they test 25 cartons and they find that their mean volume is 1002, so that's X bar. And N was 25, it's 25 cartons. The mean is supposed to be 1005, we can just ignore that for now. But we get 998 up to 1006. I'm going to go through significant figures here. So we know that the mean is somewhere in between there, or 1005.9, whatever it is. Use the 95% confidence interval to assess that claim. We cannot reject the claim that the true population mean is 1005 mils, as that lies within the 95% confidence interval. I guess you would say we cannot reject the claim at the 95% confidence level. Okay, what the heck do I mean by this? So how do we interpret confidence intervals? Well, here's a lovely number line. There's 995, 1000, 1005, and 1010. That'll be enough. Our 95% confidence interval looks like this. So just a smidge over 1005, actually at 1006. And then this is our 95% confidence interval. What that says is we're 95% sure that the mean is somewhere in here. Could be anywhere, could be wherever. And sometimes the mean's out there, but 95% of the time it's in. So the mean could be anywhere in here. A really important thing, if I'm mentioning that like 5% of the time the mean's not in the confidence interval, what that means is there's a 5% chance that if you make a confidence interval, it just will happen to not have the mean in it, at least if it's a 95% confidence interval. If you make like a 80% confidence interval, there's a 20% chance that the mean's outside. Okay, next one, we've got cans of Coke. They claim the actual mean's 375, otherwise they're false advertising. Is the claim reasonable? Okay, so we got 120 cans of Coke. We're at a 95% confidence level. The question doesn't say, you can sort of just assume 95, but more often than not, they'll make sure to say it just so it's clear. X bar is 371. That's a sample mean. N is 120 cans, and we're going to execute that. 370.78, 370.79 is less than the mean, which is less than, and 371.21. Okay, so let's draw a number line for this lovely situation. We've got 370, 371, 372, 345, and we go 372. So our confidence interval lies in this range, 370.79 all the way up to 371.21. So there is the 95% confidence interval. Okay. They claim that the mean is 375. So this is the claimed amount. And we reject the claim. We reject the claim that the mean is 375 mil at the 95% confidence level, as the entire confidence interval lies below 375 mil. So the mean, I mean, it could be 375 in theory, anything's possible, but at a 95% confidence level, we reject that claim because we're pretty sure the mean's in this range here, and we're pretty sure that it's not this number all the way over there. Important to mention, If the claim was that the mean is less than 375 mils, this would be supported by the confidence interval. That would be like an alternative question. So yeah, interpreting it can get a bit messy. You like to not, like, you can't ever say that the mean is a number. You can say in this case that we're 95% confident the mean is less than 375. So you'd support a claim like this. But if they're claiming the mean is 375, or if they're claiming it was more than that, you have to reject the claim.